Good day. I am Professor Timothy Kentop at the University of the Virgin Islands. This is our last and final solution for CSE 465, System Security. At this point, you have already created a Microsoft Standard Server or Data Center Server that has two roles installed, DHCP and DNS. It's most important that the server be configured with a static single IP address in the range that you have on your network. If you're using the remote virtual machines, you'll see that each of your servers have a static address and a name already configured. If you're creating a local version of this solution, you'll need to change the computer name and assign it to a workgroup other than workgroup. And you'll need a static IP address outside the range of IP addresses assigned by your wireless router. In fact, if you're working the home solution, one of your first tasks is to assess the address ranges that are in play. So you would essentially pull up a view of your wireless access router. In this case, you see an ASUS wireless router, but you might have a Netgear or a Linksys. And if you look at the local area network options, they'll be arranged differently on your screen, but essentially it's usually in that group of features that you'll find something about the DHCP service that's running. In my case, you see that I have local addresses that begin with 2 and end with 21. So I can create for my custom DHCP solution anything outside that range. It's important not to overlap ranges because DHCP servers can issue the same addresses in that overlapping area, and you'd have an address conflict, and that would create a lot of instability on the network. So it's absolutely critical to know which address range you're using. The first thing you're going to do if you're creating a home-based solution is to capture a screenshot of your DHCP range to confirm the other numbers you can use. So you're going to avoid these numbers. If it starts with 2 and ends in 254, you can trim that down. You can change the ending address and apply the change so that basically you have another range of numbers to work with. If you're working with the virtual system remotely online, you will see your address range here. The address range that we're using on campus is a public subnet 146.226.249, and the last number, the XXX number here, your beginning address, if you're a Maya, the beginning address is .70 and the ending address is .79. That's the DHCP range of addresses that you'll use to configure your DHCP. Kenesha will use .80 through .89. Benaya will use .90 through .99. David will use .170 through .179. Ray will use .180 through .189. And for demonstration purposes today, I will use .190 through .199. For your first artifact for task 1, you are to email me using Outlook with your UVI email address, and you're going to get a screenshot of my confirmation of your address range. So you're going to send me an email and you're going to say, I understand that my beginning address and my ending address is 146.226.249.70, and my ending address is 146.226.249.79, and it's a /24 subnet mask, right? The gateway that you're going to use to configure is 146.226.249.1. In any case, your first artifact, rather than a screenshot of your wireless router, you're going to submit. So you're not going to submit a screenshot of your wireless router. Instead, if you're using a virtual system remotely, you will send a screenshot of my reply back to you saying, yes, that's correct. We want to make sure that nobody issues the same IP addresses. There's no overlap between those scopes. That's the first task and the first artifact that you'll submit, a screenshot of either one of those. For the second task, you're going to begin configuring DHCP by authorizing the DHCP server. If you're doing a local solution and you don't belong to a domain, you'll basically get an error. But if you are working the remote virtual system, you're basically going to go to the Tools section and then open up DHCP. And if it doesn't appear on the screen at first, it could be that it's down on the taskbar and the server manager is blocking that. I'm going to minimize this screen now, just to adjust the size so you can see it better. And for now, what we're going to do is just have this one window open. If your server is properly configured, you should see the name of the server under the DHCP. But what's most important is that when you click DHCP, you need to manage authorized servers. You have to add this server as an authorized server. Until it's authorized, it won't work. In a domain environment, this is an additional control, and it's an important matter of network security. If you're doing this in an environment where you don't have an enterprise Active Directory domain, in other words, you don't have a centralized security account management model, if you're working with local security groups in a workgroup environment, what you're going to find is that when you try to authorize the server, it's going to try to check against the domain and you'll get an error back. So this is one advantage of working within a domain. When you select Manage Authorized Servers, you're going to click the Authorize button and you'll enter the name, or actually you're going to enter the IP address of your own server. In this case, I'm using Vega for demonstration purposes, so it's 226.249.64. That's Vega's address. I click OK, and you see that it resolves my name correctly. That's a good sign. I'm going to capture a screenshot of this. Now, if I'm doing a local solution, I'll get an error message, capture the screenshot of the error message, and submit that for task 2. So that's task 2 of the solution. So either submit one where it shows that this is authorized, right? It's in a list of authorized DHCP servers because you walk through the process, or show the error message because you're doing an at-home solution. And that would be what you need to submit for task 2. I'm going to close this and go on to task 3. For task 3, I'm going to set up a scope with smaller lease time. So I'm going to stop in the process of setting up my scope on the one screen where it shows lease time, and I'll explain that in just a minute. So I'm going to select my server, and you'll see two options, one for IPv6 and one for IPv4. And I'm basically going to select IPv4. I'm not interested in creating an IPv6 DHCP scope at this time. And I'll right-click it with my mouse and select New Scope. And then I'll follow the steps of the wizard. This will be Test Scope 1. Actually, use the number that corresponds to the last IP address, the last number of your IP address for the server. So Vega is 64. I'm going to say Test Scope 64. And that way I can use the number reference to keep, if I have multiple DHCP servers, one way to keep the scope separate is to have some sort of cross-reference that I create. So this is for a trial DHCP scope on Vega, which has a .64 address, right? So I'm just gonna add that as the description so I know where to find this scope if I'm managing scopes. So my starting address, as we stated, from the the Excel spreadsheet we showed was 146.226.249. I've confirmed that, and it starts with 190, and my ending address is 146.226.249.199. I'm going to increase the length of the subnet mask because it's a /24 network, and I'm going to click Next. I won't be excluding any IP addresses, although it is common for many network administrators to add the IP addresses of fixed server IP addresses so that they're excluded from DHCP leases. That's not the best approach for this. The best approach is to use a MAC address reservation so that if a network driver resets the network interface on a server and it starts to issue an automatic address, the DHCP says, oh, I see this is the MAC address for this server, and then the MAC address IP reservation uses the same IP address that it had configured statically. We're going to skip this. Here's the setting of interest. I want to reduce the lease duration for the address to 0 days, and I want to reduce it to, say, 4 hours, so that any device or system has a lease on an IP address for a morning or an afternoon. The reason I want to reduce this down to a number of hours is that when hackers come in here and they start to reconfigure your network settings on devices and systems, if you have a lower lease duration, basically what can happen is that when the system restarts, when it goes back to automatic, you can force your devices and systems to refresh the network operations criteria more frequently, and this can make it harder for hackers to get in there and make changes that persist. So it's also better when you're rotating a smaller pool of addresses. You have to refresh those more often to have a smaller lease time. There is more network traffic, so depending on the bandwidth you have, the number of clients you're supporting, you may have to adjust that. But basically, it's better to have a shorter lease, especially when you're making changes on the network for management and assessment purposes. You want a screenshot of this. This is the third task. This completes your third task. Your screenshot showing a 4-hour lease for your scope is what you need to submit to receive credit for task number 3. Now let's go on to task number 4. We're going to finish. I'm going to configure the DHCP options for the scope. So these are scope options. I'm going to put in the router gateway address. If you're doing this from home, you'll have a 192.168.something.1. In our case, if we're on the remote systems on campus, it'll be a 146.226.249.1 address. We want to pin that to the gateway, so we want DHCP to issue that for a gateway. For our domain name servers, we're going to enter the name of our custom domain, and DHCP is going to attach that as a suffix to the end of the client names, the host names, the devices and systems. In my case, I'm creating a custom domain in honor of a Muppet character named Beaker. So we're going to create a custom domain name called beakerfans.org. We'll come back to that in just a minute. So that's what I'm going to set up on my DNS. I want to put that in here to match. If I'm going to create a domain name for Beaker Fans and a domain organization, if I'm actually going to create a whole organization on that basis. If it was a private internal domain for a corporation, you'd have something different here, but I'm just showing you what we're doing here. So beakerfans.org, this is what I'm going to, so as this network DHCP service is connecting clients, it's going to tack that onto the end of the host name. I'm going to put the server name in here, and if I put in the server name, which is Vega, I'm using Vega. I'm going to resolve that. And you see that it correctly identifies my name. If I have other addresses listed here, I'm going to remove these. Because going forward, I want to use my own DNS server, my own dedicated DNS server. So in this case, I'm going to remove and remove. But I'm going to resolve that Vega name again. Because you see, when I click to remove those, it replaced that address. I've got 64. I'm going to add it. It's validating if 64 is a DNS server. It'll validate if your system is a DNS server, and it should return a positive result. If it doesn't, it could be you need to start the DNS service. I'm going to go ahead and click Next. I am not configuring WinS. I don't want to use Netbios names. That's a bad thing to do. I'm going to leave that unconfigured. In fact, I'm actually going to add a server attribute to disable Netbios over TCP/IP and NBT. I want to activate the scope now. If I don't activate it, it won't be active. It won't work. So I'm going to click Finish. And at this point, I'm ready to take on the next task, which is to configure. Well, first I have to capture some detail about my scope. So I am going to show my scope option, but I'm going to click on here on the address pool to show the address pool. So I'm going to submit 2 artifacts for task 4. The first one showing the address pool, and the second one showing the address options. So here you see address pool and scope options. Once again, I'm capturing the first image showing the address pool with a start and end address. This should match what's in the email that confirmed my address range. My scope options should show the router address and the DNS server that is going to be used and my custom domain name that I intend to set up on DNS. That's the second screen capture for task 4. Now we're ready to go on to task 5, configuring server options. When we configure server options, we're going to right-click Server Options, and instead of using the General tab, we're going to scroll down to option 42 to select NTP servers. These are Network Time Protocol servers. If I'm going to configure custom core infrastructure on my network, I want to make sure all of my devices and systems synchronize their time precisely. The best way to do that is to configure an NTP server for my time zone. And the best way to do that is to go to the Google and search for NTP server pool and click on here, and then use the North American servers option. And as you look further down the screen, you'll discover that well, the Virgin Islands does not have its own NTP server. And actually, geographically nearby, there aren't too many in Puerto Rico either, or in neighbors. So what I'm going to do is actually select the United States, and then I'm going to put this pool number, instead of putting the first one, everybody will put in the first few. I'm going to put in the last one, 3.us.pool.ntp.org. I'm going to use that to configure my NTP configuration. So once again, in here, I'm going to put in 3.us.pool.ntp.org. I should be able to resolve this to an address, and I did. That's good news. I'm going to add it now, And now I have a pool of NTP time servers in the US that I can use to synchronize my time. I'm going to apply, and then I'm also going to create another option to disable Netbios. If I click down just a little further, you'll notice that there's some WinS, NB, NBNS. I don't want that one. The Netbios over TCP/IP, you would think that's the one. But if I use this one instead, the node type, when the address is issued to my network interface or network interface on devices and clients on that network, if I change the hexadecimal value from 0xray0 to 0xray1, then I put the network interface in a different node of operation, a different type of node. Instead of being hybrid that includes Netbios, it's a B node which excludes Netbios. So I'm going to apply, say OK, and this is going to be what I submit now for task number 5. This screenshot showing WinS NBT node type 0xray1 and NTP servers, a value for NTP servers. And that's task 5. In order for this to work, though, I have to restart the server. I've just made all these changes, and they're not loaded into the service. So my 6th task is actually very quick. I have to be ready to grab a screen capture as quickly as possible. So as soon as I right-click and I use all tasks, I can restart the DHCP service to load all these changes into effect. As soon as I do that, there's going to be a little window that pops up. I want to grab that screen, or I can grab this one. But either way, this is I'm going to submit this, or get a screenshot of this and submit that for task 6, the last task for DHCP. I can minimize my DHCP console at this point, and now I am going on to DNS. So now I'm going to configure DNS. I'm going to open the DNS tool, and here on my DNS server, I am first going to I'm going to right-click and configure DNS server so that I can use it for name resolution out on the internet. There's very little point of having your own custom DNS server unless you can look up websites and email addresses and online applications locally. The performance increase is amazing. I shouldn't have to go to my internet service provider to look up names on the internet if I have a local DNS server. So that's one of the roles that DNS servers provide. It's to provide a way to look up or resolve domain name addresses. They not only store named resource records, but they also help you look up other entries and other values for other resources online that are hosted by other DNS servers. So I'm going to select configure root hints only and hit next and hit finish. And I'm going to restart the service just to make sure I'll clear the cache and then restart the service. This is just a habit that's good to do. We'll talk about that more in a minute. But so that change is taken effect, we're going to restart the service. The first thing I'm going to do is add a new reverse lookup zone. So I am going to add a reverse lookup zone. And if you're at home, you're going to add 2 reverse lookup zones. So we're going to add, if you're using the remote virtual system, you're going to click New Zone. It's going to be a primary zone. It's IPv4. We're not doing IPv6. And we're going to type in the network ID for what we would normally put for the network identity. In this case, 146.226.249. Whoops, I'm missing a number here. So you're going to type it like you normally would type out the address. And what it's going to do is create a reverse lookup zone that appears in reverse order. That's normal. You're going to click Next. And then you're going to click Next again. And you're going to accept the default that you don't want to allow dynamic updates because you don't want hackers to change your Kool-Aid. If you're at home doing a local system, you're going to create one more, a new zone. And you're going to create a primary and a reverse lookup zone. And in the case that you have a 192.168.1 network at your home wireless, through your home wireless service, basically you could put 192.168. Or if you have 0, put 0. So now you have at least the one. If you're doing this from home, you have both. Now we're going to add the forward lookup zone. So this is the actual custom domain name. We said we were using beakerfans.org. I'm going to create a new zone. Call this, that's a primary zone. So I'm hosting these records for the beakerfans.org. If I register this and there is no other such domain publicly on the internet, then with public registration, I own that domain, and this server becomes the worldwide authority. It stores the primary zone or database of DNS records. So now I have a forward lookup zone for beakerfans.org. I also, if I am configuring this remotely and online using the virtual machine instead of a local, so what I'm about to show you next, if you're doing a local solution, you do not have to do this. But if you're going to do a forward lookup zone, what I want you to do is to create a stub zone. It's called a stub zone to point to the domain that exists with the remote systems, the virtual servers, the virtual machines at UVI that are running, that you're using remotely. So we're going to create another new zone, and instead of being a primary zone, we're going to call it a stub zone. And we're going to say next, and the zone name is groovy.net. Again, this is only if you're using the remote virtual systems. We're going to create a stub zone, and then we're going to point to the servers that are authoritative for groovy.net. In this case, 146.226.249.51 and 146.226.249.52. And that way we have a way to loop in the Active Directory domain. So now I have at least one forward lookup zone and the reverse lookup zones. If they're not showing, expand the tree to show what you've set up. If you have a local solution, you're going to have 2 reverse lookup zones and a single custom domain name, the zone for the domain name, your custom domain name. If you're configuring the campus-based remotely accessed virtual servers, you're going to have one reverse lookup zone, the 146.226.249, and it'll appear like this. And you'll have 2 forward lookup zones, the custom one that you create and the campus domain, the Active Directory domain on campus. So that's what you're going to capture for task 7. So this concludes task 7. This is what you need to show for task 7. Your screen's going to look a little differently than mine. I have both cases represented here. That's why I have 2 lookup zones forward and 2 reverse lookup zones. So once again, if you're using systems on campus remotely, you'll have one custom, the custom domain that you created, that you set up in DHCP, and you'll have Groovy.net. You'll have one reverse lookup zone. If you're doing the home version of this, you'll have your home network, the campus network, and your own custom domain name. That's it. Okay. So you capture a screenshot of this. And this is what you submit for task 7, forward and lookup. For task 8, you're going to go to your custom domain name. You're going to right-click on this side and create a new host record. You'll use Virgo, the name Virgo, V-I-R-G-O, and you're going to include this checkbox, create an associated pointer record, and you'll type in this IP address. This is a web server that you're going to use to simulate a website devoted to beakerfans.org, or in your case, your own custom domain. So the website where I'm going to host the beakerfans.org website is called Virgo. That's the host name for the web server. I'm going to check the box to create associated PTR record, and this is the address that I type in. All students, whether they're doing the home solution or the remote virtual system, are going to add this host. And it says it was successfully created. You're going to say OK, and you're going to say done. And you should see Virgo there. If you open this up a bit, you'll see the domain name there. And now we're going to create an alias. When people are on the web, we don't want them to know the name of the host, the web server, per se. So we're going to use an alias instead. The most popular alias of all is www. And we're going to browse to Virgo on Vega in our own DNS server, in the forward lookup zone, in our custom domain, where we set up the record for Virgo, and we're going to select Virgo. So now we should have our A record and our alias. I'm going to do something really important here. I want this, I've made changes, so I would normally restart the service, but I also need to clear the cache, both on the, oh, by the way, this is the screenshot that you're going to capture for task 8. So you need this screenshot showing Virgo at 146.226.249.67 and a www alias Virgo dot, and then your own domain name would appear here. This is the screenshot that you submit for task 8. For task 9, in order to make this functional, we have to clear the cache on the server. We have to clear the cache locally on our own system and make a change on our own system to use our own DNS server on our own network interface. And then we need to clear the cache locally. So that's what I'm going to do. I want 2 separate submissions, maybe 3, depending on how you do it. So the first thing we're going to do is we're going to go into our host network interface settings under Ethernet. We're going to change the adapter options, and we're going to go into properties. We're going to adjust our, by the way, if you're doing this at home, you want to disable TCP/IP version 6. You want to go in here, and you have the statically assigned one, but you've also got some other DNS server, or it shows obtain DNS server automatically. You want to select use the following DNS server address. You want to go into advanced and select DNS, and you want to remove any previous DNS servers that are in there. And then you want to add the IP address for your own DNS server. This is Vega. My address is 64. I want to use my own. So I'm going to enter 146.226.249.64. If you're at home, you're going to enter the fixed IP address of your own DNS server. But if you're on campus, you're going to use the IP address of your own system. So you're going to click Add, and then you're going to click OK, and OK, but that doesn't really operationalize the change. The problem is that we still have stuff in cache and there's a service running. So I'm going to change that setting, and actually I want to make sure that that's part of what's captured. So this is part of what you're going to capture. So this is one screenshot you're going to capture after you change, after you set up your DNS. You want your local machine to use it. So this is part of task 9. You're going to change this setting. You're also going to open up a command prompt. So if you type in CMD and then right-click this, you'll have to run as administrator. And you'll want to adjust the window here so you can see both of these. In my command prompt, I'm going to issue the command ipconfig/all. No, actually I'm going to do flush DNS first. So when I do this, it's going to show that my DNS cache has been flushed. So this is one screenshot you can capture. It shows that you've changed your local network interface to use your own DNS server, and you flush the cache. So that's one screenshot. You can close this. You need to show that you've cleared the cache on the server. There's a cache running on the server. You can capture this screenshot, and that's the second artifact you need for task 9. So you're going to capture this one. And the third thing you're going to do is you're going to capture a third screenshot showing you that you're restarting the service. You can either capture this one or capture this screen. Either way, those are the 3 that you need. So you show the local changes on the local network interface and clearing the cache on the local system. Then on the server service that's running, you cleared the cache and then you restarted the service. This concludes task 9. We only have one more task and then we have an extra credit. So we're almost done. The last thing we want to do is make sure it's working. So we're going to open up a separate browser tab. And actually, it's a good idea to make sure if something's working properly, to see if you can ping it by name. So this is just a good thing to kind of prime the pump with. If your DNS service is working properly on the local system, I should be able to ping Virgo or www.beakerfans.org. And you see I had a positive result. That's a good sign. If that doesn't work, I can try to ping directly virgo.beakerfans.org, and sometimes that'll do it. To prove that my system is working properly, I'm going to type in www.beakerfans.org. And what I should see is a splash screen for my website. So if I had set up a website here that was exclusively for Beaker fans the world over, this is what I'd see. So this is the last artifact. I need to see your custom domain and this splash screen showing. And basically, that's the last artifact that you need to submit for your final solution. Now, for extra credit, all the things we've done to set up DHCP and DNS, the most important thing to understand about that is that all of that is wasted effort unless on a switch or a router we use IP helper. It's one thing to set up DHCP with all the extra scopes that define how devices and systems will operate on the network, what they can and can't do. And those controls are important for system security. It's another thing to have your own custom DNS. Because if you have your own custom DNS server, you get much faster performance. You get to control what people are seeing. And here's an added benefit. If you view the advanced as people in your organization are using your custom DNS server, what will happen is that you can go in and browse the top level domains and see which addresses, which domain names have been engaged by people on your network. This is very helpful for troubleshooting and security assessments and so on. Basically, you can check out different results as people are searching the web, as they're engaging in email and online apps. All of those named resources are collecting here in the server cache on the DNS. Another important enhancement is that as all the clients in your domain are browsing the internet, they're using your custom DNS server and they're not using the domain controllers. So you set up the domain controllers so that they can't resolve domain names. The domain controller DNS is AD integrated DNS. It's a special kind of DNS. In any case, the point I'm trying to make is that you go to the trouble to set up DHCP, and it didn't take long. And then you go to the trouble to set up a custom DNS service. But none of that benefits you if you don't anchor it by forcing the clients that connect to your network to use the DHCP server. The way to force your clients when they connect to the network, whether it's wireless or it's Ethernet based, you use an IP helper statement. In Cisco, it's a very simple statement. But the important thing to understand is that IP helper criteria is configured in routers on the interface itself, on the router interface itself. And if you're using a switch, if you want the IP helper or DHCP helper to be enforced on a switch, that's configured on a VLAN, not on an interface. So any ports that are assigned to a specific VLAN or subnet are going to use that IP helper address. You see here a reference for Cisco, the Cisco command to configure a router, so that anything that's working through that router is going to direct connected clients to get their DHCP from your custom DHCP service. So that's one anchor. The switch configuration would apply to a VLAN. So you would go in to configure the VLAN, and then you would issue the same command for IP helper. And anything that connects to that VLAN or subnet would be directed to DHCP. Once it's directed to DHCP, how the devices and systems operate on the network is defined in terms of where it gets its named resources through the DNS service, what gateway it uses, what broadcast. You can even define static routes, time servers. You can disable Netbios, all of that. Ultimately, it directs all your clients to work through DNS. Hacking experts like to crack DNS. If you have your own custom DNS and you lock it down, it's much harder for hackers to break your network or to exploit your network. So, what's the extra credit? You can look up this particular you need a screenshot of this, not my screen, but your own screen, showing that you looked up the command to implement an IP helper setup to configure IP helper on a switch or on a router by brand, by model. You can pick TP-Link, Netgear, any managed switch. So you can use Cisco, you can use HP, you can use 3Com if it's still out there. There's all these different network brands, but what we want you to do is to go out into Google and look up how to configure on a managed switch the IP helper. It's this anchor, it's the foundation that the rest of the house is built on. And even though this is extra credit, I hope you take the extra time to do the extra credit, because the rest of the house that you just built is really only built on sand. And that's the truth. If you lock it down the moment it connects, to direct it to a DHCP, you tell it how it can operate on the network and where to get its information, and then you control your own source of named information, you've won 4 out of 5 battles in the war to secure your network. So you can include any suitable reference for DHCP helper, DHCP relay, or IP helper configuration. For extra credit, you can earn up to, depending on the level of detail that you submit, you can earn up to 3 additional points of extra credit. This concludes our review of the criteria for your final solution submission. I'm available for assistance as needed. Please don't hesitate. Don't suffer needlessly. If something isn't working, just as you saw in this video, don't hesitate to text or to email or just plain call. So you know how to reach me. Good luck on your final solution, your last assessment, and your final exam.